For years, every Magento module that needed a database table shipped a PHP file called Install Schema, full of imperative calls like create table and add column, run once and never touched again. Today we cloned the real Magento 2.4.9 source and searched it. Outside of a handful of internal test fixtures that exist specifically to test the migration mechanism itself, there is not one install schema file left anywhere in the real core codebase. In its place, 76 DB_schema XML files, and 82 matching whitelist.json files. Today we open the real machinery that replaced setup scripts, the schema declaration itself, the whitelist gate that stops it from silently dropping your data, and the Diff engine that turns a declared table into actual SQL. Welcome back to Magento Development Deep Dive. We've covered how Magento boots, wires dependencies, dispatches plugins and events, and stores attributes through EAV. Part 8 covers how a table gets created in the first place. Declarative Schema, the system that replaced the old install and upgrade scripts. Every source file today was pulled from a real local git checkout of the exact pin tag, 2.4.9, so the line numbers on screen are ground truth. By the end of this part, 5 things should click. Why core modules stopped shipping install schema and upgrade schema PHP files entirely, replacing imperative table building code with a declaration of what the schema should look like. What a real DB_schema XML table declaration actually contains, line by line. Why a second file, the whitelist.json, has to explicitly agree before certain changes are even allowed to run. How the Diff class and the OperationsExecutor class cooperate to turn that declaration into real altered table and create table statements. And why data patches as opposed to schema never went away, and still run as ordinary PHP classes to this day. Strip away the code, and declarative schema is 5 stages. Declare, a module ships a DB_schema XML file describing what its tables should look like, not how to build them, just the end state. Whitelist, for certain changes, a second file has to explicitly list the exact table, column, or index being touched, or the change is silently ignored. Diff, on every setup upgrade run, Magento compares the declared schema against whatever the real database currently looks like, and builds a list of differences. Execute, that Diff gets walked, one operation at a time, and turned into real SQL, wrapped in a single transaction per table. And patch, none of this touches actual data, inserting rows, migrating values, which still runs as an ordinary PHP class implementing an interface, exactly the part that never got replaced. A few things help before we dig in. Part 7, on EAV, is useful background. The EAV_attribute table we opened there is itself declared through this exact declarative schema system. Either a real Magento 2.4.9 checkout, or the GitHub tag open in a browser tab. Basic familiarity with SQL tables, columns, and JSON files is enough. No prior Magento 1 install script experience required, if anything. Forgetting how the old system worked makes this easier to follow. This is the real, opening slice of the sales_order table declaration, straight from the pin tag. There is no PHP here at all, no create table call, no add column call. Just a description: this table exists, engine InnoDB, and it has an entity ID column, a state column, a status column, each with its type and length spelled out. Somewhere else entirely, a piece of framework code is responsible for turning this description into a real table. That's the entire point of declarative schema. The module says what should exist, not how to build it. This is the real opening of the matching whitelist file for that same sales_order table. Every column we just saw declared has a matching true entry here, by name. This file isn't optional decoration, it's generated once, by a CLI command, and then committed to the module. The moment you understand what it's actually checked against is the moment declarative schema stops looking like bureaucracy and starts looking like a safety net, which is exactly what the next file shows. This is the real core of canBeRegistered, and it answers the question the last 2 files raised: what is the whitelist actually for? The very first check is the important one. If the operation isn't in a known list of destructive operations, the method returns true immediately and the whitelist is never even consulted. Only operations Magento considers dangerous: dropping a table, dropping a column, get checked against that JSON file by name. Ordinary additive changes, like adding a new column, don't need whitelist entries at all. The whitelist is a break on deletion, not a gate on every change. This is the real, trimmed shape of OperationsExecutor's execute method, the class that actually runs the migration. It asks the diff for every table history, and for each one, it walks every configured operation: add column, create table, drop element, and more, collecting the real SQL each one produces into a single statement aggregator per table. Only then does it hand that batch to the schema writer to actually compile and run. One table, one aggregated set of statements, one transaction, not one query per tiny change. This is the real core of AddColumn's doOperation method, one concrete operation class, one job. It takes the new version of a column straight from the diff, turns it into a real column definition string, and hands that off to the schema writer, along with the exact table and connection it belongs to. Every operation class create table, drop element, modify column follows the same shape, read the diff, produce a statement, hand it back to the executor we just saw. That's the entire declarative pipeline, end to end, from an XML tag to a real alter table. These are the real, complete bodies of both interfaces, and notice, they're empty. Schema patch interface exists purely so a class implementing it can be recognized as a schema patch, but declarative schema now handles table structure entirely on its own, so writing a new schema patch today is effectively pointless. Data patch interface, on the other hand, is just as empty but very much still alive. Declarative schema only ever describes structure. It has no opinion about what rows exist in a table. That job stayed exactly where it always was, an ordinary PHP class. This is the real core of PatchApplier's apply data patch method. First, a check most people never think about: has this exact patch already been recorded as applied, in which case it's skipped entirely, forever. Then, unless a patch explicitly opts out by implementing non-transactionable interface, it runs inside a real database transaction begin, apply, commit, or rollback on any exception. That's the guarantee. Declarative schema itself never made for structural changes, but data patches still do, every single time. This is the real apply method from sales own order statuses data patch, plus its version declaration. No XML, no declaration, just an ordinary class, implementing data patch interface, called once, in order, tracked by that version string so it's never run twice. It builds a sales setup helper and installs the actual order status rows pending, processing, complete, cancelled values that could never have been expressed as a schema declaration, because they're data, not structure. This is exactly the class of work declarative schema was never meant to replace. A few things trip people up here. The whitelist only gates destructive operations, so a missing whitelist entry for a brand new column does nothing at all. It's only when you try to drop something that the file suddenly matters. That whitelist file has to be regenerated through its own CLA command and committed whenever a destructive change is genuinely intentional, or the change just silently never applies. Data patches are still ordinary PHP, which means the usual footguns apply: get the version string wrong and get version, and Magento can end up rerunning a patch that was never actually supposed to run twice. And reordering columns inside db_schema XML does nothing at all. Declarative schema has no concept of column order, only of which columns exist. Let's pull declarative schema back together. db_schema XML declares what a table should look like, and real core modules have zero remaining PHP create table code to maintain. db_schema whitelist.json only gates destructive changes, checked by Diff's canBeRegistered method. Additive changes need no entry at all. OperationsExecutor walks the resulting diff and turns every declared change into real SQL, batched one table at a time. Schema patch interface is effectively deadweight now that declarative schema owns structure, but data patch interface is very much alive, still running as ordinary transactional PHP. And a real data patch, like sales own order statuses patch, proves the point. It's still just a class implementing apply, exactly like setup scripts always were, because data was never declarative schema's job. That's how Magento's declarative schema actually replaced setup scripts, straight from a real git checkout of the pin 2.4.9 source, every file and line verified against that exact commit. Part 9 goes deeper on data patches versus schema patches, and what it actually takes to write an idempotent upgrade. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in Part 9.